Okay, today is September 13th, 2018, and right now we have clear skies in Los Angeles. The temperature is about 75 degrees, and the barometer is reading 29.89 inches. All right, so I don't have the humidity data or the dew point data. Right now we're looking at Hurricane Florence. This is a Category 2 storm, and looking at the hurricane map, we can see that it's scheduled to move in by today, later tonight, and then slow down. Looks like they're going to stall it, and it'll move across the South Carolina area and then hook back north by Sunday, Monday, and Tuesday. Looking at the pressure data and the speed, we see that Florence is now a Category 2. The storm is being worked on. Sustained winds of 105 miles per hour, central pressure of 955 millibar, which is still a fairly strong storm, and moving northwest at 10 miles per hour. So the storm has slowed down, and we see there's a number of other storms out here. We've got Isaac, which is forecasted to move along the Caribbean in a westerly direction. We've got this new development here with a 50% chance of hurricane formation. Take a look at that here on the SSEC map. We can see right here this area which is developing. Here is Florence. Let's go back to the floater map and we can see what's going on here. A hole was blown into the side of this storm. Right there we see the big area of that void right there. The eye wall has been disrupted. We can really see this in the visible light map right here. I'm going to go ahead and stop this loop and we'll scroll through it frame by frame. We can see the very beginning of this sequence. Right here is where the storm was targeted. The eye wall is approximately in this area. It's already been disrupted. And so we see the satellite transmitter targeting this area. We see an expanding pressure wave right there where the water vapor has been superheated. We see that expand out, and then we have that big void that we just saw in the infrared map. All right, let's go ahead and run this. Okay, so now let's go take a look at the infrared map, and we can see where the targeting was done. Right there, that blew a hole right into the side, right around the center of the storm. And so the eye wall has been disrupted because of all the convective process has been disrupted by the superheating over here on the side. That's what's causing the eye wall to fall apart. And of course we have these pressure waves which move out, and we have this icicle pattern, this blast pattern all the way around. That's the evidence of the superheating process. So the water vapor inside of this hurricane is being superheated. It's pinpoint targeted and superheated, and that is causing the rapidly expanding water vapor. And of course the visible light map confirms this. We can see what happened right there. We've got those pressure waves that move out radially from the center. Now the main point I'm making here that should be made is that this storm could have been knocked out way out here in the Atlantic. This is being allowed to move in. The key thing here is the amount of power that's used to weaken the storm. And this is just they're putting on a show. It looks like they're making some efforts to knock it down, which they have. But again, this should have been done 1,000 miles out off the coast, much like we've seen in the Central and East Pacific all season long. All the hurricanes we've been watching in the Pacific have been knocked down pretty much. These weather controllers allowed a major storm to move fairly close to the islands, the Hawaiian Islands, a couple of different times. But this thing here should have been knocked down, completely destroyed, much like we saw with Olivia here just the other day, a couple of days ago. Here is the North Pacific. Of course, there's no rain in California. We continue to see this low pressure system here was completely squashed out. We can see there's really nothing left of that. Here we have another low pressure system up over the just out here in the West Pacific with a right angle on it. It's not exactly a right angle, but we see that that's not Mother Nature or CO2 or smokestack emissions causing this oblique angle there. And we see the remnants of Olivia moving right over the Hawaiian Islands right here. So we'd like to hear from the people in Hawaii how much rain you got and what the conditions were like. We see water vapor streaming into California right over central and northern California. That's probably being sprayed over. Since there is no rain in California, the spigot remains off. Here is the surface analysis map for the Atlantic. We see this is, let's get this map queued up right here. Here we go. Florence, right here, 957 millibar. And let's take a look at the swells that Florence is generating right here in the center, 45-foot seas. So this is going to bring some very, very high surf to the coastline. That's the most current map right there. We've got 45 right dead center, and then we have 42, 30, and 24-foot seas all the way around this the center of that storm. Okay, so on the Central Pacific, we have Olivia, 35-mile-per-hour winds. This has passed over the islands, 1,008 millibar pressure. Now let's take a last look here. I'm just kind of going out of order, but here is the SSCC upper level tropical water vapor map, 6.2 micrometer wavelength. We can see Florence moving in. So this is intimidating. These people should have knocked this storm down, and they're flexing they're showing us their power, what they can do, and these people have to be stopped. The uplinks and downlinks that control the transmitters which are able to do this need to be identified, located, and the people who are running those transmitters and the software need to be identified, and all this has to be reined in. And I hope that the White House is listening, because this has to stop. We've got millions, 120 million dead trees just in this state alone. The water supply is being controlled. Fresh water is becoming a big commodity. All this has to stop. Okay, that's it. We'll do another update later.